class, if you a follower of mine, you observe that in our last class we derived a formula for calculating the length of an arc of a given word circle. So today we are going to be solving some practical questions in relation to that. Okay. Here we are given that an arc subtends angle of 105 degrees at the center of a circle of radius 6 centimeter. Find the length of the word arc. And we have to take pi as the 2/7. Okay, to make this question of more easier and practical oriented, I'm going to sketch this very word question in form of a word, a diagram, so it will be as a guide in solving this. Okay, so first of all, I want to sketch our circle, having the circle, this center of the circle. Okay, and we are told that the circle has a radius of what 6 centimeters. So any line drawn from the center to any part of circumference in the word is a radius. So here we have 6 centimeters. Likewise, we have a replica of this on our right hand side, 6 centimeters again. Okay. Now the distance apart between this radius and this other radius is what? The angle of 105 degrees. So you have 105 degrees. Now, what are we asked to find here? We are asked to find the distance from here. Let's say here is A and here is what? B. What is the distance from this very place, following this path, this curved path, okay, to this very spot? This path from A down to this word B is an arc. So we have to find the length from here to what? This very point, okay? And from our explanation last time, that is the formula of calculating that length of an arc, okay, is equal to what? Theta over what? 360. Multiply the word, perimeter of the word, is circle, okay? So from our question now, let's write out our parameters. Our parameters are such that our angle is 105 degrees, okay? Our radius is what? 6 what? Centimeter, okay? And we are told to take pi as 2/7. Okay, now going back to this formula, substituting each of these parameters in this formula, I'm going to have L be equal to what? Our theta is what? 105 all over what? 360. Okay? Then multiply by 2 times our pi is what? Is 2/7. Okay? Then our radius is what? 6 centimeters. I'm going to have this as 6 centimeters here. Now, what do you observe? These are numerators. Why these are what? Denominators, okay? So the denominator and numerator, if they have any common factor, that can be factored out, okay? So let's take this 6. 6 in itself is 1. So we are left with 1 centimeter here. 6 in 36, that gives us what? 6. 6 in 0 is what? 0. So we have 6 here, right? Now, what is common again? We observe that 2 is also a factor of itself and 6. Okay? 2 here is gone. 2 here is what? 30. Okay? What is the common factor again? 3 can go here and 3 can as well divide this, right? So 3 in 30, that gives us what? 10, right? Then 3 in 10 gives us what? 3. Remember 1. 3 in 15 is what? 5. Okay? And what is again? 7 here, 1. 7 in 35. That is what? 5. Are we together? So from here, we observe that 5 is also common. 3, 7, and what? 10. 5 here, 1. 5 in 10, that gives us 2. So we are left with what? 22, right? And 2. 2 here, 1. 2 in 22, that is 11. So this 11 and this 1 centimeter. Obviously, the length of the arc will be equal to what? 11 centimeters. If you like, you can go as far as multiplying everything out by saying 105 times 2 times 22 times 6. You write out your answer at the numerator. Then coming back to the numerator, you can say 360 times 7. Then write down your answer at the numerator. Then dividing the numerator with the numerator. The final answer you get is what? 11 centimeters. So from this, you can see that the length of this very arc from here to this very place is what? 11 centimeters. So thank you for joining us. We hope to see you in our next class.